Here we have the file for the consensus sequences for mid2 HLA-B, exon 2 forward and reverse primers, and exon 3 forward and reverse primers. And I found 2 consensuses for each of those primers. Now, what we're going to do is that we're going to convert these consensuses into allele calls, and we'll do that using the IMGT HLA reference database. Now, what I'm going to do though before we do that is I'm just going to make a deliberate error in one of the consensus sequences. I'm just going to change this T to a C so that I can show you what may happen if you made an accidental error when you called your consensus sequences. So we're going to copy the consensus sequence, and then I'm going to open a web browser to the link which has been provided in the steps file for the HLA BLAST tool. Here we go. So we're going to perform a nucleotide BLAST search. We're going to use the IMGT HLA coding sequence database. Paste that consensus in with the deliberate error in it and submit. And it runs a BLAST search, so we need to be patient. It doesn't take too long. And when the BLAST search is finished, it will bring back what it believes are the best matches for the consensus we pasted in. And the columns which are of great interest to us are the positives and the E-score. So what the positives tell you is what percentage of the bases which it lined up against the reference sequence were a perfect match. So we have 99.4. And then the E-score tells you what the probability that the sequence you pasted in could have matched that if it was just randomly by chance. And so we have e to the minus 91, which is very close to a 0 chance that it happened randomly. Now, the reason we have a 99.4% match is hopefully because I corrupted our consensus sequence by changing one of the bases. But this may happen to you if accidentally you made an error when you generated your consensus sequence. So to fix this, what you do is that you show the alignment. And the alignment shows that we have a mismatch in this position here. All the lines which go down are matches, but where there's a space in this position here is an error. So what I would do is that I would copy all of the sequence prior to the error. Copy. And then I would return to my consensus sequence, and I would search for that, what I just copied. And so the error supposedly happens just after that. And then I would return to my file where I generated the consensus sequence from, HLA-B exon 2 forward. And I'll just sort that out as we did previously. Sequence sort. That one there was the nice reference. And again, I'll search for that piece that I copied from the web browser. And I can clearly see that it should have been a T straight after there. I go back to here and I had a C. So that's obviously my error, T. Now, one thing that you may have noticed is that when I searched for that piece, I'll just do it again, search for it. It doesn't start at the start of the sequence. It's actually started 90 odd bases in. So why is that? Just to explain that quickly to you. When we chose the database from which to do our BLAST, we chose coding sequences. And Whereas when we have sequenced, we have not just sequenced the coding sequence, but we've also sequenced the introns between. So our primer is intron based and starts before the exon starts. And so we're sequencing part of the intron and then we start sequencing into the exon. Whereas we have blasted against a database which is only the exons. And the reason we've done that is because the next step that we're going to do, or the last step that we're going to do in calling our HLA alleles, is based solely upon exon sequences. If instead we had done our blast, against the IMGT genomic HLA database, just do that now for you. Again, please be patient, it doesn't take too long. And if I have a look at the alignments, of course, because we fixed that error, we now have a 100% match. If I show the alignments, you can see that it's starting from query position 1, but I'll just validate that by copying that bit and going back to here. And start at the start. So basically those first 70 bases or so are intronic and not included in the coding sequence database. Okay, so let's go back to the coding sequence database and do this blast. Copy. Paste. Submit. Plenty of waiting when you're doing this step, unfortunately. Suppose if you want to be hyper efficient, you could open up multiple windows in your web browser and get them all running at once, and that may save you a little bit of time. Okay, so now we see that we have the 100% match, and the e-value is actually even lower, so the chance of it happening due to random chance is even closer to 0. 94 zeros is pretty close to 0 though, decimal point 9.4 zeros. What you'll notice is that we have 50 sequences here that have 100% match and the same e-value, very close to 0. But what we don't know is, were there more than 50? And so what we need to do in this, another step that I didn't show you, is that, so going back, is that we need to select IMGT HLA coding sequence database, paste in our thing, select more options, and instead of 50 we want the top 1000. This will give us a bit more breathing room, and submit. Unfortunately it takes a little bit longer as well, but not too much longer. Okay, so now you see we have our 100% positives. Scrolling down, 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 we have a lot more than 50 of them. Okay, 99.4, as we probably remember, was the score we had when we had one mismatch. Okay, 100% positives go down to 576. So what we're going to do is copy all of these. Copy that data and we'll paste it into Excel. And I've found that it actually works best if when you paste it into Excel you use a paste special with match destination formatting. You can try doing it the normal way, but I think that for me it works a little bit better. The pasting takes a little while to happen. Now, when it pastes in, you notice we've had to copy all of the columns. We really only want this column here, which has the allele calls in it. So I'm just going to delete the first 2 columns. And I'm going to delete the last 5 columns. Also, you'll notice that the column which had the allele call in it also has these extra lines, cross-references and related information in, etc. And we don't need all of that. So we're just going to sort this column just alphabetically, data, and then A to Z sort. And the allele calls all go up to the top because they all start with B. So I just do the scroll down until I get to the rest of the information which we don't need. Select the first row of that. Scroll down to the bottom of the sheet. Shift, click on the last cell and just right click and delete those extra rows. And now again you notice that there's actually still more than we want. The allele call is B07020101, but then after that it has 1089 base pairs, which is basically the length of the reference sequence that was used. We're not interested in the length of the reference sequence. So I'm not an Excel guru. I'm not going to give you a lesson on Excel. This is not about Excel. And you may well know how to do these things better than I do, but for those who aren't Excel experts, I'm just going to give you a formula which you can use, and you can just copy what I'm doing. But if you know a better way of doing it, please go ahead. So the formula is equals, and we're going to take the left-hand side of the data in cell A1, and the amount that we want to take is we're going to look for a space within cell A1, and that's when we find the space, that's as many as we want to take. And that's pretty much what we want, just B07020101. And I'm just going to go down to the bottom and then just going to copy that formula down for all of those. And then I'm just going to copy those cells, put them in a new sheet. And when I paste them, I have to paste them as values. I don't want to paste the formula. Paste the values in. And as the label of that column, this is mid2, HLAB, exon2 forward. This was the A consensus. And then what I'll do is I'll repeat that for the other 7 consensuses which I gathered from mid2 HLAB. And once you've done all that, I'll see you for the next video. Thank you.